Good morning, students. Yesterday we are discussing about the essential requirement of the instruments. So in that we have studied that is deflection system and control system. So today we will discuss about this damping system. Okay. Now we will study what is damping system. Here during deflection of the pointer will oscillates due to inertia. So while it's coming to rest, okay, so before coming to the rest of that pointer, so it will oscillates for a moment due to inertia. So that oscillation will be reduces. Okay, so that can be reduced by this damping system. Okay, so here the pointer, okay, so to bring the pointer to rest within a short time, so we need damping system. Okay, the reduce to reduce that oscillation oscillating of the pointer. Okay, so that can be done by this damping system. Okay, so in the damping system, see here simple waveform. So here there are three conditions. Okay, so here over damp and critically damp, and this is under damp. Okay, so if that oscillations were okay, so oscillate for a more some more time, so and it will come to steady position, that is under damp. Okay, if that that okay, so the moving system reaches steady positions rapidly and smoothly here. See, okay, so that is critically damped. Okay, so and if that moving system run like this, okay, that is it will take a more time to reach its steady state, that is called as over damped. Okay, so these are the three conditions. So normally your damping system will work under these conditions, that is under damped conditions. Okay, so this damping system where there are three types in the damping system. So first one is a air friction damping system, and fluid friction damping system, and another one is eddy current damping system. These are the three methods which we are going to install in the particular measuring instrument. Okay, so now we will see one by one what are these things. Okay, first one is air friction damping system. So here we have a air chamber, and here we have piston. That piston is connected to this pointer. Okay, so whenever your pointer start moving, so it will the piston move upwards and downwards in the chambers. Okay, so to maintain this steady position, it will move upward and downwards in the air chamber. Okay, so when the this piston move upwards, here the air pressure increases. Okay, so that your needle will sets its final position without any oscillating. Okay, so here in the air friction we are using air inside this air chamber. Okay, so to maintain the final position, to steady position of this pointer, this is the air friction damping system. Okay, in the same way we have another one, that is fluid friction damping system. So this is also similar to this air friction damping system, but instead of air we are using a fluid here, a separate oil, that is damping oil we are using in this system. Okay, so for this we are using a small disc here. Inside the oil we have placed a disc, and that disc is connected through the spindle. Okay, so when your pointer start moving, so this spindle is start rotating. So due to this rotation, your disc is also a rotation. Okay, so this rotation can be opposed by this fluid. Okay, so that your pointer will rest in a final positions. Okay, so that will this fluid will produces the damping torque. Okay, so this is the second method, that is a fluid friction damping method. Okay, this is the third one, this is eddy current damping. Okay, so when the pointer starts oscillates, the aluminum disc under the influence of magnetic field of the damping magnet, this disc will cut the fluxes, okay, and causes an EMF in the disc. Okay, so this will, due to this moment, this disc will start rotating. So when this disc is come under this magnet, it will cut this magnetic flux. Due to this cutting of the fluxes, your EMF will be induced in this disc. Okay, so due to that EMF will opposes this flow of current here, or this will opposes the relative motion of this disc. So in that way your pointer will stop, or it will reach its steady position without any oscillating. Okay, so this is eddy current damping. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಇಲ್ಲಿ ನಿಮ್ಮದು ಪಾಯಿಂಟರ್ ಮೂವ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು. ಸೊ ಪಾಯಿಂಟರ್ ಮೂವ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು ಅಂದರೆ, ಸೊ ಇದು ಡಿಸ್ಕ್ ಇರ್ತದೆ ರೀ, ಈ ಡಿಸ್ಕ್ ಏನಾಗುತ್ತೆ, ರೊಟೇಟ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಸೊ ಇದು ರೊಟೇಟ್ ಆಗಿ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಳಗಡೆ ಬಂತಪ್ಪ ಅಂದ್ರೆ, ಸೊ ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಫ್ಲೋ ಆಗ್ತಿರ್ತಾವೆ, ಇಲ್ಲಿ ಏರೋ ಮಾರ್ಕ್ ಇದೆಲ್ಲ, ಸೊ ಇವು ಏರೋ ಮಾರ್ಕ್. ಸೊ ಇದೇನಾಗ್ತದೆ, ಇದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇದು ಡಿಸ್ಕ್ ಏನಾಯ್ತು ಅದ್ರ ಮೇಲೆ ಹೋಯ್ತಂದ್ರೆ, ಆ ಡಿಸ್ಕ್ ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡನ್ನು ಕಟ್ ಮಾಡಿದ್ವು. ಸೊ ಓಕೆ, ಸೊ ಆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಟ್ ಆಗೋದ್ರಿಂದ ಈ ಡಿಸ್ಕ್ ಒಳಗಡೆ ಏನಾಯ್ತು ರೀ, ಇಲ್ಲಿ EMF ಪ್ರೊಡ್ಯೂಸ್ ಆಯಿತು. ಓಕೆ, ಸೊ ಡ್ಯೂ ಟು ದಿಸ್ EMF ಯುವರ್ ಎಡ್ಡಿ ಕರೆಂಟ್ ಸ್ಟಾರ್ಟ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ದಿಸ್ ಡಿಸ್ಕ್. ಓಕೆ, ದ್ಯಾಟ್ ಎಡ್ಡಿ ಕರೆಂಟ್ ವಿಲ್ ಅಪೋಸಸ್ ದಿಸ್ ಪಾಯಿಂಟರ್ ಮೂಮೆಂಟ್. Okay, so that this pointer will reaches its steady position. So this is eddy current damping system. Okay, so these are the three methods of the damping system. Okay, so by this your first chapter will complete. Okay.